Yeah, probably not yet.
What are you doing?
Trying to get us home faster.
What?
Excuse me, stewardess. Why is the plane doing this bendy thing?
You mean following the curvature of the Earth?
Map looks flat to me, so can you tell the pilot to fly straight? We're trying to get home.
This world is not what you think it is. This world is not what you think it is.
Thank you.
Can I ask the pilots one question?
Ah, the first officer's here.
Do you mind?
He's got a question for you. Oh, yeah.
Hello, mate. How are you?
Yeah, good.
I'm a fellow, Casey Josh, I'm a fellow just PPL pilot
Cool.
here.
Yeah, nice.
I got a couple of serious questions to ask you.
Okay, here we go.
Yeah, it's a big time. Curvature.
Curvature.
Yeah.
Yep.
We don't allow for curvature, do we?
For anything, not really usually. Yeah.
No, we're round. We're a disc, aren't we? Round and flat.
Yeah. Sorry.
Hey, well, honestly, quite seriously,
Yeah.
we are, aren't we?
Yeah.
Thank you, mate. Thank you for being honest. Can I ask you one more serious question?
Yeah, go for it.
I just got one question to ask. Flat or a ball?
Flat or a ball? What's that?
Well, I never feel as breaking round. If we live on a ball, surely we'd have to fly around it. Yeah, it feels like flat or a ball.
Flat. Not a ball. I think it's flat.
Yeah, me too.
Pretty flat to me.
It certainly does, doesn't it? And you've got that flight instrument down there to keep it flat.
Gravity exists.
Gravity? There's an unproven theory.
No, it's not.
Let's rock and roll. Cheers, fellas. Thank you very much.
Are you the pilot? Oh, okay.
Yes.
Am I allowed to say hi? Hey, I just want to say thanks for the smooth flight.
Great.
I did have one question. Is there like a specific angle of downward tilt you have to fly at to
3 degrees.
3 degrees
That's it.
for the curvature of the Earth?
Oh, for the Earth?
Because
No, we just fly over the troposphere.
really,
Yeah,
but
yeah.
do you have to keep like kind of going down because?
No, we actually have to nose up. It flies like that.
Really? Because I was reading some stuff on the flat Earth that made a lot of sense. Have you looked into it?
Which one? Sorry.
I was reading a lot of stuff on the flat Earth.
Okay, yeah. True.
It's true?
Yeah.
Okay,
Yeah.
alright, cool.
All
Hey,
right.
God bless, brother.
Alright, have a good one.
You too.
I'm fellow pilot. Can I have a quick word with the pilots? I just want pilot talk. I just want to ask them about something.
Pardon?
Something about the plane. Just pilot talk. Thank you. Yeah, absolutely, I understand that these days. G'day guys.
How you going?
Just a fellow PPL,
Oh yes.
you know,
Yeah,
but yeah. Casey, how are you, mate?
Nice to meet you.
Pleased to meet you guys.
Yeah.
Guys, I'm going to ask you a question.
Yeah.
I've been flying,
Yeah.
and I've come to the conclusion
Yeah.
there is no curvature. I never allow for curvature. There's no way there's curvature. We're round and flat, aren't we?
Definitely.
We are, aren't we?
Flat as a
Thank
pancake,
you,
mate.
sir.
Flat as a pancake.
We're and the outer ring is south,
Yeah.
and so north must be in the middle, correct?
Possibly.
That
Yeah.
would be the only way that a
Yeah.
magnetic compass works on a flat plane.
Might be on something there.
Yeah,
Might be
but
something.
you're not having me on. We
No,
are.
no, no,
We're round and flat,
Flat
aren't
as a
we?
pancake, mate. Yeah. There you go.
Thank you, man.
No worries.
You made my day.
Only the people at Jets don't know that.
But,
Yeah.
yeah, well,
There you
you know,
go.
I tell a few people, especially some close mates, even
Yeah,
though
yeah.
even though I'm a pilot,
Yeah.
they laugh their heads off at me.
That's
Think I'm
it.
an absolute nut job.
Ah. Nah.
Hey, thanks, guys.
No worries, mate.
Cheers.
Cheers.
Thank you.
Take a look here. This newscaster is standing on. This is a representation of the flat Earth. One thing even more interesting than the flat Earth model itself is take a look as they show a model of a plane flying above the flat Earth.
Just one seat. But just as the Wright brothers couldn't carry passengers, Solar Impulse represents the first steps in solar-powered flight. And to prove its potential, they began flying it around the world, from Abu Dhabi.
This is exactly how a plane flies over the flat Earth.
Last year, with stops in India and China, then across the vast Pacific.
And how the sun works as well. In most cases, of course, you're going to take a direct route. But this is basically simulating how a plane flies. It does not go around a ball. The plane always keeps its nose up. Okay? Anybody that's ever flown on international flights, you never feel like you're going around or you're going upside down on a globe or a ball Earth. It's because you never do. You're flying above a plane. It's exactly what's taking place here. And this is all about mockery.
Remember, it has no fuel. It was on to the United States, hopscotched across
There you
America,
go.
powered only by the sun.
Nothing
and now it has
but
crossed
mockery. Nothing but mockery.
Hi, I'm Daryl, and I'm a realist, also known as a flat earther. One thing that we deal with as being flat earthers is the scientific community. We'll post pictures, memes, we'll post videos, we'll post facts, figures, different experiments that have been conducted in the past, but not so much recently. And that often results in people saying that we're discredited because we don't have any scientific backing for what we believe, although there's tons of evidence. So, what I'd like to do is submit a new experiment to the scientific community. This is very simple. A lot of people don't fly a whole lot. I fly fairly regularly, at least every other month. And one thing that anybody can do, this is a simple experiment that anybody can conduct to determine definitely that the Earth is flat. You know, grab $10, go down to your local hardware store, pick up one of these spirit levels. Doesn't have to be this brand. I'm not getting paid by Swanson to promote. Grab a spirit level and take it on the plane with you. Now, I say take it on the plane because if we're living on a spinning ball or a globe that's 25,000 miles in circumference around the equator, according to curvature math, then the plane should be constantly dipping its nose forward in order to compensate for the curvature regularly during flights. But I don't know anybody who's actually reported that happening, and thus far it's just been speculation. So what I'm going to do, I'm going to take my spirit level onto the plane and prop it to a point to where it's level, and I'm going to record the fact that the bubble stays perfectly centered. And while that bubble's staying perfectly centered, it's going to be rather anticlimactic, but that's proof that the Earth is flat. It is what it is. You know, they call it a spirit level for a reason. If you put this thing on a flat surface and it stays, this bubble stays in the center, that means it's level. Sorry, if we're not constantly dipping the nose forward and the bubble isn't going towards the backside of the spirit level, then we're compensating for curvature. You're not going to see that. So, Currently, I'm on location at the Savannah Hilton Head International Airport in Savannah, Georgia, and I'll be taking a short flight over to Charlotte, North Carolina. And once I get on the plane there, I'm going to do a 20-minute time lapse. Now, we're going to be on a A321 airplane. Max speed for that is 541 miles per hour. I'm going to do a 20-minute time lapse. That should cover about, let's say around 180 miles. If we're going 180 miles over a curved surface, or over the curved Earth, as curvature math suggests, then that means there should be compensation for over 4 miles of curvature. So, that's the experiment. I'll keep you posted. Stay tuned. Let's get ready to fly. Okay, so now we're on location at the Charlotte, North Carolina airport. I'm on the way to my terminal. Getting ready to do this experiment. This is going to be fun. Let's get ready. Now that the plane's at cruising altitude, let's start the time lapse. Alright, back in Seattle. You saw it here. I decided to go ahead and do 23 minutes on the time lapse. And if my calculations are correct, that should have brought us over right around a little over 200 miles that we covered. And as you saw, there was no compensating for curvature. So I guess that pretty much settles it. The Earth is flat. Well, I guess that concludes this video. So since the last video, gotten a few comments back concerning the spirit level experiment to determine that the Earth is flat. Now, one of the retorts that I've gotten was to simply look out of the window in order to see the curvature. curvature of a horizon. We'll talk about that later, but I'm on the way to another flight. So, let's see what happens when I look out of the window for curvature. So today I'd like to take this time to invite you to take a flight with me. A lot of people subscribe to the idea that you can simply get onto a plane and look out of the window in order to see the curvature of the Earth. However, I'd imagine that some of these individuals who say such things haven't really taken a whole lot of flights and probably haven't spent a whole lot of time looking out windows. So, while we have this time together, let's enjoy the beautiful scenery here and the complete lack of curvature with a quick vocabulary lesson. Curvature. Let's go over the definition of that. According to Wiki, in mathematics, curvature is any of a number of loosely related concepts in different areas of geometry. Intuitively, curvature is the amount by which a geometric object such as a surface deviates from being a flat plane or a curve from being straight, as in the case of a line. But this is defined in different ways depending on the context. I'll just stop there. We all get a pretty basic understanding of what curvature means, but on this flight there are going to be points where I show you that you're not seeing any curvature. And the idea of looking out of a window over a horizon in order to see curvature, well, that's an oxymoron. And that's just not my opinion. The two words, curved horizon, yeah, those don't really fit. Now, let's go over the definition of horizon. The line at which the Earth's surface and the sky appear to meet. Synonyms, skyline. Okay? But the word horizon comes from the word horizontal. And what does horizontal mean? Parallel to the plane of the horizon, at right angles to the vertical. Synonyms for horizontal include level, flat, plane, smooth, even. One of those words from horizontal, while we're at it, on this vocabulary lesson, enjoying the non-curvature, is the word plane, which is fitting because at the time I was on an airplane. So, what does the word plane, P-L-A-N-E, mean? A flat surface on which a straight line joining any 2 points on it would wholly lie. Synonyms: flat surface, level surface, horizontal. A horizontal plane. So we've come full circle with all these. And the definitions pretty much speak for themselves. The fact that anyone thinks that they can simply look out of a window and see a curved horizon just doesn't really make any sense. Oh, also, you'll notice during this flight how close the sun seems to be. We're told that it's 93 million miles away. I'm going to go ahead and object to that in this video because you can obviously see the intensity of the sun's light right above the surface. You may also notice, just look, the glare is just down there, and the intensity of the sun, it just shows so brightly on this side as opposed to the other side. Now, if the sun were 93 million miles away, that light would shine across the surface of the Earth evenly, but it's not that far away, and it's not as large as we're told either. But I'll save that for another video. I just think it's cool how I was able to look out of the window and see that small, close sun the way that I was able to on this flight. And you're probably wondering, well, are you just going to record the whole flight? Yeah, from start to finish. I'm recording the whole flight. And there's plenty of opportunity for you to look out of the window with me. And I thank you for being here. Look out of the window with me and notice that there is no curvature. And I'll say it again, said it before, you're going to hear me say it again in the future. The Earth is flat. And if you look out of the window simply for curvature, I'm sorry, you're going to keep looking and you're not going to see it. It's just as simple as that. And I just wanted this to be clear evidence of that fact. So, you know, we're getting close to the end of the trip. This was a flight from one place to another place. Very short flight, about 45 minutes. I'm trying to be discreet here. But, you know, that's just what it is. There is no curvature to be seen out of the window of a plane. And the sun isn't as far away as we've been told. That's just what it is. This was a 45-minute flight, and I wanted you to see what it's like to be able to just look out of the window for curvature. And this is my answer to the skeptics out there who may not fly a whole lot. I'm not mad at you, and I understand the cognitive dissonance may kick in when you hear someone say that the Earth is flat, but it is. And I hope that this is sufficient in showing you evidence that, one, the Earth is flat because you can't see any curvature on the horizon, and that the sun is not 93 million miles away. And if you believe that the sun is 93 million miles away, I'm sorry, you need to take some classes in perspective, get your eyes checked. You know, it just lends evidence to the fact that you may be a little detached from reality. But the sun isn't 93 million miles away. The Earth is flat. There is no curvature to be seen from a plane. You saw it here. Good morning. This is a response video to those out there who have objections to the details of my spirit level flight experiment. It's another rebuttal video. Thus far, I've showed that a plane flies over a level surface. Another thing that I was told after the experiment was to simply look out of the window to view curvature from the aircraft. So I took you on a flight where we looked out of the window the whole time. During that flight, there was no observable curvature to be seen. According to the heliocentric model, the spinning ball Earth, we're told that at the equator, the Earth is spinning at 1,032 miles per hour eastward. Now, because the United States is a little higher in latitude from the equator, let's say that the speed slows down to about 850 miles per hour. Now, I was on a plane heading from the East Coast to the West Coast at 515 miles per hour. The cruising altitude anyway, or cruising speed, is 515 miles per hour on an A321 Airbus. The max speed is 545 miles per hour, according to online specs for that particular aircraft. Now, given those numbers, I conclude that an East Coast to West Coast flight should be a physical impossibility. Now, why do I say that? Well, for example, and I'll just use this to make things simple. The plane is only going 515 miles per hour. The ground beneath the plane is moving at 850 miles per hour. Therefore, the ground is always outpacing the plane over 300 miles per hour. So, being able to fly from the East Coast to the West Coast, that should never happen. But what happens? Well, people book their flights, they get on the planes on the East Coast, and they fly to the West Coast with no problem. Planes go from the West Coast to the East Coast, generally the same amount of time. A flight from Seattle to Texas, Houston that is, takes roughly 3.5 hours, both ways. From Houston to Seattle, about 3.5 hours. From Seattle to Houston, about 3.5 hours. Now, if the ground were spinning beneath us, that shouldn't happen. That should never happen, if you think about it. And that's all I want you to do. Just consider these things. because it's pretty common sense stuff. What does happen? Just that. Everybody makes their flights on time. The times are always right around the same, going both ways. Almost as if we live on a flat, stationary Earth. Because that's what it is. Now, before we get into this next part, let's listen to a pilot's testimony.
I was an airline pilot for Delta for 26 years. A pilot's primary flight instrument is his artificial horizon, which he has to be maintained level to keep from climbing and descending. From the cockpit, weather permitting, I could see hundreds of miles in all directions, viewing cities connected by roads across the flat plain as far as the eye could see.
Alright, so now number 2, what should have happened on the spirit level flight experiment. According to the heliocentric model concerning spherical trigonometry, the curvature of the Earth is calculated at 8 inches per mile squared. Now, in my experiment, if you've seen that already, I'll post a link in the description. I traveled 203 miles recording level flight. During that 203 miles, according to curvature math or spherical trigonometry, the plane should have had to compensate for 5 miles of curvature going downward. But while explaining that, it seems that some people misinterpreted what I was saying. In my head, I didn't go through each step. Actually, I'll admit it, I skipped a step. So here, let me grab my model. Now, what I showed you was level flight for 203 miles. Bubble stayed centered the whole time. Generally the whole time. Now, had the plane been dipping the nose forward, the bubble would have ended up towards the back of the spirit level, like so. But that's not what happened. What I showed in the flight was that the level stayed flush pretty much for the entire 203 miles. Now, even so, it showed that the plane was flying generally level. Because the plane was independent of the Earth's surface during that flight, that means in order to maintain altitude of 34,000 feet, which is what I was told, which is what we were told on the plane. 34,000 feet was the cruising altitude. So in order to maintain that, while flying level, the only way that the plane would have maintained that altitude while the Earth's surface was curving beneath it would be to decrease velocity and thus cause the airplane to slowly sink in order to maintain that altitude while the Earth is still curving beneath it. Now, let's say that is what happened, and the plane was just flying level, and it was decreasing altitude, or just flying at a speed that would constantly compensate for the curvature of the Earth beneath. Yet and still, even at the end of that, at the end of that 203 miles, the plane still would have had to compensate for curvature, because you see, the plane was still independent of the surface of the Earth. So the plane was flying level, but the ground beneath, according to the heliocentric model, the ground was still curving beneath the airplane. So the plane's flying level, and the ground's still curving beneath. So at some point, in order to get proper orientation back to the ground, the plane would have had to take a dive, or dip the nose, as I say. But that didn't happen, and you saw that. So one of two things was supposed to happen. Either the plane was supposed to fly off into space, because it was just flying level the whole time, and it would have gained too much altitude because the ground is still curving beneath it, right? Or the plane was just flying over a level surface the entire time, which it pretty much shows that the Earth is flat. Mosquitoes. The surface is sloping at an exponential rate while the plane is flying, just like that. Now, I know before this experiment even starts that the plane does not dip its nose forward. I know that. During takeoff, the plane dips the nose upward, tips upward, tilts the nose upward, then it flies nice and level at cruising altitude, maintains an altitude over a flat surface, we're in the air flying over a plane, and then decreases velocity when we get closer to the airport. Then we land, deploy the landing gear, wheels come out, bottom wheels hit, front wheels, and we're back at the terminal. That's how a flight goes. The plane never dips its nose forward. I know it, you know it. And that's what happens. The plane just flies level the whole time because we're flying over a flat stationary Earth. There's the proof.
Hello Flat Earth researchers, debaters and debunkers. This is the Spirit Level app and the smartphone that are used in an experiment to test whether there is any curvature of the Earth between two locations about 6,000 miles apart, or 10,000 kilometers, between Phuket in southern Thailand near the equator up to London in the UK, stopping off at Dubai. This Spirit Level app has two interfaces, this one here showing level, which changes if we just move it slightly, and this one with another bubble level, which is pretty much center at the moment, but this also shows roll, which is reading at 0.0 degrees, and pitch, which is reading at 0.9 degrees, and any slight changes in those levels will be picked up by the app. Now what's important here is that people will argue that the accelerometers in mobile phones that are used by the apps to determine level rely on the force of gravity telling them which way is down and therefore which way is flat and level as a horizontal. So I will show you how this is calibrated and can be calibrated on a slope, which I've set up here to believe that the slope is its new level. So this will show you how the app is used in the experiment, and that any changes between the original calibrated level at the departure point and the destination most definitely will be shown by the app. So what we're going to do is put it on the slope here, and you can see that it knows it's on a slope. The bubble's up here, the roll is still 0, but the pitch is 25 plus degrees, and on the traditional view this bubble is right up here and this one's still level. So we can calibrate this to make it believe that this slope is a flat, level, horizontal surface. So what we do is we click calibrate here, and we have some choices. The way to force this app to believe that this is its level is to do number 1, which is lay flat and touch cow, which we're doing there. Okay. The next one to do is to stand the phone horizontal and click cow. So we're going to turn it this way and have it on that same level, and that's that. Skip the rest. Calibration complete. So it is now going to think that this is its new level. You see, we know it's on a slope, but this is in the middle and this is in the middle, and on this one the bubble is in the middle. It's showing a roll of 0.12 and a pitch of 0.1 or 2. Okay, so it now believes that this is level, and when we put it on the flat table, it believes that there's the bubble over there, and the roll is 20 and the pitch is 14 degrees. So the app now believes that the table is not flat because of being calibrated on the slope. You can see here that the bubble is way off on both of these, even though it is on the flat table. But when we put it back on the slope, it goes back to reading level on both of these. Okay, so this shows how the app can be programmed to determine what its original level is, and therefore read any changes in that level. So, on with the experiment. This is Phuket International Airport, and they have a spirit level app on my phone here. You can see that when we tilt it, it moves. We can also change the view. You see here the bubble is in the center on the floor. You can see that it's sloping, okay, as it moves on its own, okay. And the bubble is now over here. What we can do is calibrate. Alright, so that's, and then we can stand it horizontal. Oops. And calibrate. Okay. Skip. So now it sees that as level. Yeah. Alright. You see, even though it's on a slope, it thinks it's level because that's where it was calibrated. If you put it back on the floor, you can see that when it was on the slope, it was made to think it was level, and now that it's on the flat floor again, it's out of sync. Okay. Alright. So it thinks that this is level. Okay, the bubble's in the center. Alright, so we can turn the phone off. Okay, that's off. Turn it back on again. Start up. So this is to show you that even after turning off and on again, the app should remember that this chair that is sloped is its level. Okay, just wait for it to load up. So I'm going to fly to Dubai and then on to Heathrow. So I'm going from pretty much near the equator up to the northern hemisphere. So go and find the app again. There it is. Spirit level app. Okay. And as you can see, it has kept that in its memory. Put it on the floor again, and the floor's level, but it thinks it's out of whack. So now I'm going to calibrate it for being on the level. Okay, let me just stand this up again. Calibration complete. Okay. So now it's back level on the floor. put it on the slope. It's now off. Okay. Yeah. So it's been calibrated on the level. So, let's see how it is in Dubai. Alright, I'm at Dubai airport now. Let's have a look. Oh, there it is. Spirit level. Alright, dead center. So, nothing's changed. Just arrived at Heathrow and put this baby on the floor. It's still level. Okay, here's the fact.
Yeah, probably not yet.
What are you doing? Trying to get us home faster. What? Excuse me, stewardess. Why is the plane doing this bendy thing?
You mean following the curvature of the Earth?
Map looks flat to me, so can you tell the pilot to fly straight? We're trying to get home.
An historic moment today in aviation. For the first time, a solar-powered plane has crossed the Atlantic Ocean without using fossil fuel. The Solar Impulse 2 landed in Spain today, 3 days after taking off from New York. As Eric Sorensen explains, what was once thought to be impossible is now a reality.
What it is an airplane that shows what future air travel may look like. Yes, it's almost as wide as a football field is long with just one seat. But just as the Wright brothers couldn't carry passengers, Solar Impulse represents the first steps in solar-powered flight. And to prove its potential, they began flying it around the world, from Abu Dhabi last year, with stops in India and China, then across the vast Pacific. Remember, it has no fuel. It then was on to the United States, hopscotched across America, powered only by the sun. And now it has crossed its last ocean, the Atlantic.
not much further to go.
As Eric Sorensen explains, what was once thought to be impossible is now a reality.